This video introduces the concept of using sprites inside of a Pygame program. In the case right now, I've got a Pygame window open, and where I move my mouse, I've got a red sprite, and when it collides with a black sprite, the sprite goes away. And in fact, if I take a look at my Wing IDE here in the background, as I collect these sprites, the number down there at the bottom of the screen goes up for every sprite that I collect. This allows me to keep score, and it will allow me to do other things such as manage bullets, manage interaction between different objects, do walls. Sprites are a very useful feature inside of a Pygame program. Let's go over the code and see how this works. To begin with, this program is pretty straightforward. We've got a standard introduction going on right here where I've got some comments. I've defined some colors right here, black, white, and red. Not very fancy. And I'm importing both the Pygame library for the sprite support, and I'm importing the random library so that I can randomly place the sprites on the screen. This next section is very important. I'm creating a brand new class called Block. I recommend that you don't just stick with Block. As you start creating more sprites in your program, actually name the class something that it represents. For instance, if the class represents a cat, call it class cat. Don't keep calling it class Block just because you've copied it from a prior example. This class Block derives from Pygame Sprite Sprite. This is the parent class right here, parent class. And this is the package that the class is in. It's in the Pygame Sprite package. I'm telling the computer to pick up every single option that the Sprite class has and add it to my Block class. And then I'm just going to add additional functionality to it. Next up right here, I've got the constructor. This def init is called every time I create the Block class. In addition to creating a block, I need to pass it these three items: the color of the block, the width of the block, and the height of the block. If you're copying this example for your own purposes and you no longer are specifying a color, width, and height, for example, if you're using some sort of graphic, then you can remove these particular items. Don't keep leaving them in because it'll just confuse things later on if you've got variables that need to be passed in that aren't used. Okay, next I'm going to call and initialize the parent constructor. This allows the Sprite class itself to initialize and get going. Next, I'm going to create a blank surface to draw on. And in this particular case, I'm going to fill the blank surface with whatever color is specified. You don't necessarily need to create a surface if, like, for instance, you're loading a graphic image which ends up creating its own surface. Once I've done that and I've filled with the color, the next thing I need to do is create a self.rect. So I've got a brand new variable here. It's a rect variable. The rect variable actually has four values: an x, a y, a width, and a height to specify the rectangle. And I'm setting it to whatever the image happens to be. If this passes in an image 20 by 20, then it's going to get a rect 0, 0. By default starts in the upper left, and 20, 20, 20. When I want to move the block to a new location other than the top left corner, what I'm going to need to do is whatever points to the block, like if I had B, I'm going to need to do b.x equals my new location, b.y equals my new location, and I'm set as far as where I want that block to be. Right now, because this is the initialization, I'm not setting a location other than the top left of the screen. Whenever I create a block, I'm going to need to give it a new location. Okay, initialize the game. We've done that before. Create the screen, the width, and the height, and set the display mode. I've got a screen that's 700 wide, 400 tall. This part's new. I'm creating a group. Whenever I manage sprites, often I'm going to have a lot of different characters on the screen, and rather than individually manage them, I'm going to manage them in a list. In this case, I've got a block list, When you create your own game, name this something that makes sense to you. Alien list, cat list, dog list, whatever. Don't just keep it as block list. And I'm going to set that it's equal to a brand new class called group. This is the group constructor right here. It's creating a new instance of group and assigning it to the variable block list. Group acts a lot like the other types of lists that we've used inside of Python, with one particular exception, and we'll talk about that in just a sec. I'm going to manage multiple lists. In this case, I've got a block list and an all sprite list. I like having two lists. In this case, I'm going to use one list. Anything that my mouse cursor collides with, I'm going to check for in the block list. When I want to draw everything on the screen, I'm going to call the all sprites list. When I check for collisions, I need to check against a list of sprites, and in that case the block list is going to serve me well. I don't want the user in that block list, because then the computer will say, well, yes, the user is colliding with the user because they're both in the same space, and I'm always going to get a collision. That's not what I want. The block list is going to have just the blocks in it. The all sprites list is going to have everything in it. The cool thing about sprites is I can tell it, draw this entire list, and it'll go through and automatically draw every sprite for me. So in that case, I like to have an all sprites list that allows me to just do something for all the sprites. Next up out here, I've got a loop. This creates the blocks. In this case, I'm creating 50 blocks. If I wanted more or less, I could adjust that. I'm creating the blocks as black. Remember, this is my width and this is my height. I can adjust the size of the block by changing those numbers. If I'm loading a graphic, or if I'm going to predefine how big those blocks are up in my class, then I want to remove them from down here. Remember how I talked you would set a block's location by block? This is my pointer to my block class. Each block has a rectangle, and each rectangle has multiple attributes, x, y of where it is, and a width and a height. By default, when we create the block, it's at 0, 0, the upper left corner. I don't want all my blocks to be in the upper left-hand corner. It doesn't make for a very interesting game. Therefore, I'm going to set the x and y to a random width and height. Now, this isn't perfect, because if you think about it, the screen width and the screen height, screen width was 700 and height was 400. Therefore, if I set the block upper left-hand corner to random locations in here, it is possible that the block could actually be drawn here or here and just barely have this top left corner fit on the screen. Ideally, really, I should have screen width minus the width of the block, minus 20, and screen height minus 15 to make sure that the blocks appear entirely on the screen. Once I've created the block, I add it to my two lists, the list of all the blocks and the list of all the sprites. I'm going to create one more block. This represents the player. I do not add the player to the block list because the player is not a block. Well, really the player is a block, but I don't want him in that list. Now I do my standard done equals false clock like we've done in other games. In this particular case, I'm getting the mouse, X and Y. We've done this before. In this case where it's different, once I get the position, I go down over here, I grab the X and Y out of the array, and I'm setting the player's X and Y to the location of the mouse. Therefore, I grab the mouse, grab out the X, Y, set the player's sprite to that particular X, Y, and then I'm set. Okay, sprites are pointless if they can't actually collide or interact with other sprites. To interact with those sprites, I'm going to call the sprite collide function, and I'm going to say, check the block list. Does the block list collide at all with the player? It's going to remove any colliding block with the player. If you set this to false, it would not remove the block. Now in this case, I'm going to say go ahead and remove the particular block and go ahead and return me a list of all colliding blocks. The length of this list is going to be 0 unless I actually collide with a block. And this right here will check. If I collide with 2 blocks, it's going to return a 2. 2 is greater than 0. I'm going to increase the score and go ahead and print the result. Now, I don't actually like the way this is done because when people copy this, it tends to confuse them. So actually right now, I'm going to change that here just a little bit. What works best and what people usually want to do is have something happen to each one of those blocks. If you do while block in blocks hit list, this is just like looping through a list. You can use the same form, and what's going to happen is that for every block in this block hit list, it's going to take one of those blocks out and put it inside a block here. I'm going to add 1 to the score for every block that I've hit and go ahead and print it out. Therefore, if I hit 2 blocks at the same time, this block's hit list will be a length of 2. It'll put each block here in turn, add 1 to the score, and print it out. I've got, if you remember, a total of 51 things to display on the screen. 50 blocks, 1 player. The really neat thing about sprites, if I've got all the sprites in the same list, I can sit here and do all sprites list.draw. We'll draw every sprite with 1 command. This draws all 50 sprites, 1 command. So much easier than what I've done before with individual drawing commands.